This is Jason Rute, who works at IBM Research, and he's going to tell us about the last mile.
Yes. So I want to talk about how do we make AI theorem provers which work in the real world for real users and not just on benchmarks. And there's a lot of disclaimers that come with this talk. It's intentionally provocative. I probably will offend everyone. The opinions are my own, not those of my employers or my co-authors. The ideas aren't necessarily novel. Others have said these same things. Um, I could be wrong about the solutions that I propose. I could even be wrong about the problems that I think are going on. I'm certainly one of the worst defenders and a huge hypocrite for in this space. But I have been thinking about this stuff for a long time, and I hope that this talk will at least be interesting and discussion worthy, if not helpful. So I think it's been like 6 years now, or about that. We've had these papers come out that say, AI models can prove about half the theorems in your favorite interactive theorem proving library, and more recently, AI has done very well on competition math problems, things like the International Math Olympiad with AlphaProof, or the mini FDEF benchmark with systems like DeepSeek Prover. And so why haven't these systems been turned into real tools for real interactive theorem proving users? And basically the one thing we have that people seem to speak fondly about is hammers. But hammers have been, here for a while. Why don't we have more than that? And why hasn't the feedback to these current systems that have been built and tried to like gear themselves towards users like Lean Copilot, LLM Lean Tactician, Cockpilot, etc. Why haven't that been positive? And I think some would say, including many who work in this space, would say, well, they just aren't good enough yet. They aren't good enough yet, and no one wants to use them because they're not good enough yet, and that's fine. We'll make them better. But I claim that the technology, I think, is good enough for a lot of use cases, but we aren't building the right sort of tools and assistance. Um, and I worked in a startup for a while after I left academics and before I went into AI research. And in the startup, we had a nice big tech stack, around our particular domain. And we'd go out and get customers, and then we'd have to build interfaces between our tech stack and the customers, and focus on the customer's needs. And we often called this the last mile. It's like in some sense it shouldn't be very much. We have all this technology, but it does feel like a lot of work, and it's often very hacky, and you have to be very kind of focused on what does the customer need. Um, and I want to talk about what I think are some of the problems in this space. Um, and first I want to talk about the parties involved, because it's helpful to think about who are all the different parties involved. So there's users, and users of these interactive theorem provers like Lean. There's novice users who are just coming to the system for the first time and are very confused. And there's expert users who just really want to do better. And then there's governing bodies, for Lean, that's like the Lean FRO, but it's also like the Mathlib maintainers and some other people who have some kind of charge or say over at least development of certain parts of Lean or Lean's related components. And then there's various AI labs. There's industrial labs and academic labs. These labs are, I mean, very focused on publishing research, or, if you're in industry, maybe it's less on publishing, but it's still on building, cutting edge AI tools. And they're really more focused on the cutting edge than practical concerns, unless it's practical within your like particular company. And then there's startups, and startups are like looking to make money. And so everyone has their own concerns, and they might not be aligned with other people's concerns, and it's helpful to understand kind of that situation. Uh, Also, another thing I got from my startup days is this notion of user stories. Like if you're building a product, a software product, it's really helpful to think about how the users would use it and come up with stories related to that. And there's different users, they're gonna have different stories, and you're gonna have different tools or applications that fit their needs. So here's 4 stories I came up with. They're certainly not comprehensive. Alice is a new ITP user. She is confused where to start. She is very, sorry, I gotta move my Okay, she's very frustrated that she cannot even prove a simple fact. She wants her code editor to suggest next steps and maybe also some kind of built-in chatbot. Bob, on the other hand, he's a power user. He can prove 10 lemmas before breakfast, but there's so much more work to do. He wants tools to make him 10 times more efficient. This includes proof automation, but also general purpose coding support. Catherine is working on a long-term formalization project. She wants tools which will run overnight on a server, closing simple goals, learning from current code base, or even formalizing parts of her LaTeX blueprint for her. And Doug is a mathematician exploring new ideas in his field. He is formulating conjectures that he would love to be able to prove or disprove automatically with AI. He's willing to be a guinea pig partnering with AI experts. And again, these are different users with different needs and experiences, and different tools would be needed. But still, it's important to think about users and what users want. A good user experience and a bad user experience is not just about how good the tool is. It's about whether the inconvenience and the benefit, which one outweighs the others. So a bad user experience would be something like this. A researcher is open source their state-of-the-art model and some kind of code to interface that with Lean. The installation is a huge pain, so basically no one tries to even install it. They provide a model to run locally, but it heats up the laptop. It barely solves anything in a minute. They also provide a way to use a large language model API, but if you do that, you're going to rack up like $100 in cost in the first day. No one's going to adopt a system like this. Now, this is of course a straw man, but it's the right idea of a bad user interface. A good user interface would be something like this. Um, Interactive Theorem Prover ships an AI assistant as part of its standard setup of its system. It's easy to set up. It has good documentation, good tech support. It's been designed with user experience in mind. It's very far from state of the art, but it provides good, unobtrusive advice when it works. And to entice users, there's a free web version to try it out. And the Interactive Theorem Prover power users and advertisers maintain it. And I think in some ways the sledgehammer in Isabel, I haven't used it personally, but I've heard people kind of say things like this, and maybe I'm overselling it a bit, but this is, I think, an idea of what would a good user interface be, and maybe it's a bit idealistic, but it's something to think about. Okay, and so benchmarks, we've been doing very well in benchmarks lately, and I think those in the know realize benchmarks are not realistic to the user experience. The test problems are often too similar to the training problems. This is less true in Coq because in Coq, it's more common to train on some packages and test on other ones, but still there's some of that. But in other theorem provers, you take the training theorem could be right before the testing theorem, and that just creates kind of too close of similarity to be practical. Or the test problems are from competition math, which was kind of fine until people started kind of gaming the system. So once you realize it's competition math, you gather all the competition math problems you could possibly find, you train models on that, you because it's an important benchmark, you spend lots of compute on it. And it's not clear that this, how much this generalizes. Now, there's very few benchmarks, I think, around the things that interactive theorem prover users care a little bit more about, things like auto formalization, program verification, verified code generation, or real world mathematical verification. Also, with any benchmark involving large language models, if the benchmark theorem has been on the internet for more than a year, there's a large chance that that theorem has already been in the training data. And this is especially true of benchmarks that are prove this theorem that's been in the Coq library for 10 years now or something like that. And then it's hard to compare methods, which it makes it really hard. So you have different ITPs, you have different benchmarks within those ITPs, and you have different computational limits. Everything from 5 minutes on one CPU to 3 days with who knows how many GPUs and stuff. So there's a large difference there. I also think there's a lack of communication between the different parties involved. AI researchers and ITP maintainers don't coordinate very much. So AI researchers are constantly remaking the same tools over and over again that I think could be more incorporated into into the ITP or things more closer to the ITP. Um, startups, startups just kind of drop things. Symbolic AI and neural AI researchers, I don't feel like there's a lot of communication between them. In particular, a lot of the neural AI papers are all like, we compared the hammer against the hammer and we do much better. And I don't feel a lot of response from the hammer folks who might say, well, that's not what hammers are used for. That's not how you use a hammer, or you're not running it right, or um, but I just don't think there's like a conversation there, and that's kind of interesting to me. And no one is communicating, I think, with users in that users should be more involved in creating benchmarks. Users should be more involved in the design of AI tools and even what kind of tools are built and what sort of research is focused on. Okay, and since this is more of a user, conference I'm at right now, I'm gonna, bash on users a tiny bit too. I mean, I don't think users are very willing to try out experimental tools. Um, and because that involves that means they have to try new things, they have to sign up for APIs, they have to use the command line, they have to mess around with lake files, they have to use WSL if they're Windows users. They have to run something, maybe try to run something overnight, not just run it for 30 seconds. They have to troubleshoot a bug and give feedback. And so they give up on tools very quickly from my experience. And this is, I think, kind of just led to some frustration of the people who are making these AI tools. Like, users aren't even going to want to try my tool, much less, take the time to work with me to make it better. And so, like, why do I even want to bother messing around with trying to create something for users? Um, and so that's good to kind of understand that too. And I've been there. I've been there as a user, being like, I can't install this right now. I have other things I have to do. I'm not going to work on this. Um, I also think there's a lot of technical challenges with making real tools that aren't showing up in these papers with the benchmarks. How do we keep lemma selection databases up to date? Like if you have premise selection, lemma selection, that database is going to get out of date. How do I host a model locally or do you host the model locally in your machine or in a cloud via an API? Each has their advantages and disadvantages. How do you make a system that's easy to install? Like how do you make since the Lean conference, how do you make a system for Lean that uses AI that's easy for the user to install and doesn't just break every time there's a Lean version bump? Um, how do you keep an AI system up to date as the library changes? Um, and there's some papers kind of exploring this, but I think there's a lot of work needing to be done on this. And how do you incorporate proof search, which is usually done at the tactic level, with awareness of the surrounding code, which is usually done at the editor level? And maybe in Lean, something like the language server is the way to go, but I don't think there's enough work done on that either. Okay, so I'm going to give you some concrete proposals um, that are specific to the Lean user community. I gave this talk once before, more focused on AI researchers, but now this is focused on more Lean users. So I'm going to give a few proposals. These are free to take or leave or discuss. For Lean users, one is keep track, and this is, I mean, nothing is that specific to Lean. So if there's Coq users here or Isabel users, same advice. Keep track of what you like AI to do. Are there obvious theorems or goal states that AI can't solve? Are there easy auto formalizations that AI tools can't do yet? Keep track of those. Make lists of those things. Ideally they should be minimal working examples or Git permalink, something that's very reproducible, so that we could go back and collect them, turn them into benchmarks. Or if not formal benchmarks, at least like things that you can try in the future and see if models have improved on that. And ideally, they should be collected in a similar place. For Lean users, if you're the type of Lean user who's like, I would actually like an AI assistant, and I know there's a lot of good things going on in AI now, what's something I could try out that'd be easy to install? Here is my recommendation. I have no connection to either of these products. They're not companies I work for. No one's paying me to give this advice. This is just my understanding of what I've heard are kind of the best things right now. So there is an IDE or an editor called Cursor. It's a VS Code fork. And then there is a language model called Sonnet 3.5. It's by Anthropic. And Sonnet 3.5 is probably the best language model for working with Lean 4. Other models really mix up Lean 3 and Lean 4 syntax. Now, the con is that Sonnet's going to cost you money. I think I've heard, about the first 2 weeks of it is free, but then, you have to start paying. Uh, Cursor is an editor which aggressively edits your code. Like, if you ask it to fix a bug in one part of your code, it might change another part of the same file. I've heard of it changing definitions in a way that are subtle and people didn't realize till later. So it may introduce bugs in your code. If that's a little too much, again, you could just turn the editor off and not use it. But if that's too much, you could use a VS Code plugin like continue.dev or Google or a GitHub Copilot, which aren't as aggressive about editing. And you can still use this Sonnet 3.5 model. And of course, anytime you're sending your code over the internet, there's a privacy concern that you have to consider if that's acceptable for you. And anytime you install a new editor, it's going to try to take all your files and say, I'm going to be the editor that the default editor for these files. So, that's always the worry there. Now, if you do something like this, share your wisdom, share what works, share what tips and tricks to make these tools work. Especially if you use advanced things, like if you know kind of advanced setup that makes it work better with Lean, share that. Again, if Cocker Isabel, same thing, share that sort of information if you know that. Okay. Another specific suggestion I have is starting an Lean AI tools user group. And by this, I just mean a group of Lean users who like experimenting with cutting edge technology, who aren't afraid of lake files, who aren't afraid to send some feedback if installation doesn't work. They're willing to try to install some of these laptop-based tools and give them a go. Things like Lean Copilot, things like LLM Lean, things like LeanAid that we just saw talk of, Duper, if that's ready to be used yet, Improver, and other things as they come out. And why not also try, if you're familiar with other interactive theorem provers like Cock or Isabel or Hall, try those tools as well. And so then you can compare, kind of across tools. And sort of have fun, experiment, give feedback on the setup process. If you have a GPU, you might even want to try some of these things that require a GPU, like Rute Prover or DeepSeek Prover or Intern LM Prover. Some of these are just language models. They don't have Lean connections. Some do. And if you like a tool, you can write getting started posts to help others use the tool. You can work with the people who design the tools. If someone says, hey, is there a tool that can do X? You can say, yeah, I have that tool installed. Let me see if it works. Let me see if it helps with problem X. Okay, so another suggestion I have is going to require a little bit more work, but rather than having users start out trying to install these AI tools on their own system where it's hard to install, it's hard to get things working, what if they're in a web editor? Now, I mean, there's a few options. One is there's already a default web editor for Lean. Could some of these tools be installed there? There is cost issue. How expensive are these to run? How expensive is that to maintain? Will they be overused? And or for the people making the AI tools, you could fork this and then install your tool in that and pay to have it hosted for a little bit to showcase your product. And that's a lot easier than having users try to install it themselves. And it'd be a good advertisement for your new model when it comes out. And then final Lean specific suggestion is I think it's really hard for people to install things on their own computer. But there's another approach, and that's to have things on a more central server that can run. And one way to do this, which is similar to a paper that came out a few months ago called Lean Agent, is many projects have stories in them, and you could set up a central server that has GPUs and everything, um, and all these different AI models installed, and then when it would just go through these various lean repos and try to solve the stories in them. And if and you keep track of things like, can any of the models solve the stories? How long did it take the model to solve the stories? How much did it cost if especially if there is some cost associated with using a LLM? What were the resource usage in various statistics? And then it's a lot easier than having someone install it on their own laptop. And it's practical in that this is actually, a way that people could use these tools. I was talking with Alex sorry, I can't pronounce his name right, Kontrevich, about this, and he thought it'd be very useful for some of his kind of blueprint projects. Um, and but also it'd be very informative. We would have a better sense of like what tools are actually helpful in practice. Um, we could ask questions like, what if we let these tools run longer? Because they're just running on a server, you could run them longer. Does this in the end speed up these long projects, these blueprint type projects? And which problems are best suited for what kind of models? Now, of course, there's practical issues of like who pays for this and maintains it, and is there ways to keep costs down? Like you don't want to be running on the same stories over and over again, and if nothing's changed, so you want good checkpointing or something. Maybe you don't want to run on all stories. Maybe you want to run on the stories that have been like read, marked in some way to do this. But these are all, things to think about. Okay, I don't have a lot of time, so let me just really quickly go through and just mention some things I like, just really quickly. So I like hammers. I think it's great that Lean's building a hammer. I think it'll be interesting to see how that plays out. Um, I think premise selection, lemma selection, is still incredibly important, and we need to really work out some of the practical issues of that. I do like this Magnus Hammer paper, and like the one sentence description of what Magnus Hammer is instead of using a sledgehammer, because all at least the Isabelle sledgehammer does is a very advanced form of premise selection or lemma selection, is just do the lemma selection directly instead of using an external automated theorem prover to do it. And it'd be interesting to see if that actually works in practice. Um, uh, I think if one wants to build theorem provers that are easy to install that work on your local machine, we might want to experiment with things that are not neural, like older machine learning methods like KNN. And I think Tactician's a very interesting approach to this. That's fast, it works well, and something that'd be interesting to try to implement in Lean. I also think there's a lot of papers coming out now that realize large language models aren't that bad at this sort of thing. They just make a lot of mistakes, and we need to fix those mistakes. And so there's a number of papers, including the Lean Aid talk that we just saw, that says, well, we could try to fix these things automatically using symbolic approaches, and maybe then call the large language model again in an iterative fashion. And so there's a number of papers exploring that, and I think that's an interesting line of research too. And code assistants like Cursor and others, we should even though many of them are designed without Lean at all in mind, I think they're still fairly good at this sort of thing, and we should be paying attention to how good they are and how they improve. Um, I do like when features get more centralized, like the try this feature in Lean, like any tactic can use try this, and that makes it a very convenient feature that lots of people can use. You don't have to re-implement it every time. I like ASIP, including the fact that it actually has a good support for connecting with AI models. And I did an experiment once where I was trying to connect something with ASIP, and it worked fairly well. And I like these web-based search tools like Lean Search and Moogle. And again, the fact that they're on the web, I think, makes them very easy to use, and that shouldn't be discounted. Of course, they don't work for your own custom projects, which is, something to think about as well. Okay, that is the end of my talk.